Alright, so in this problem, I have 5 to the power of x is equal to 10. So obviously, I want to find the value of x here, seeing that as that's the only variable, so I want to find the value of x. So for my solution, I'm going to first start by rewriting my equation. So my equation is 5 to the power of x is equal to 10. And to start, you can already tell that x is going to be some number between 1 and 2. Because if you plug in x as 1, you get 5. And if you get x as 2, you get 25. And this means that x is going to be a decimal and not a whole number. So to start off, what I'm going to do is I'm going to take the log on both sides. So I have log 5 to the power of x is equal to log 10. And the reason I did this is because if I have something in the form log a to the power of b, I can move this exponent b to the front, and this is going to equal b times log a. So in this case, I have log 5 to the power of x, and we can think of a as 5 and b as x. So I can move b, or x in this case, to the front of the logarithm. And this is going to equal x times log 5 is equal to log 10. So now I want to simplify this. So log 10, I'm going to simplify to log of 2 times 5, because 10 is equal to 2 times 5. And now if I have something in the form log a times b, this is equal to log a plus log b. So log 2 times 5, that's going to equal log 2 plus log 5. And now if I divide both sides by log 5, these two cancel out, and I get x is equal to log 2 plus log 5 over log 5. And this simplifies to 1 plus log 2 over log 5. Alright, so in this problem, I have x to the power of x plus 1 is equal to x. So to solve this, I'm going to start by subtracting x on both sides. So then these two cancel out, and I'm left with x to the power of x plus 1 minus x is equal to 0. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of x plus 1, this is going to be equal to x to the power of x times x to the power of 1. Now I have this minus x is equal to 0. Now if I factor out x, I get x times x to the power of x minus 1 is equal to 0. So now this gives me two equations. I have x is equal to 0, and I have x to the power of x minus 1 is equal to 0. So x equals 0. This is already a solution. Now for x to the power of x minus 1 equals 0, I'm going to add 1 on both sides. So then these two cancel out, and I get x to the power of x is equal to 1. Now, because x has to be the same number, we obviously know that, well, what number to the power of itself is equal to 1? That's going to be 1, right? Because 1 to the power of 1 is equal to itself. So x is equal to 1. And there's no other number that when you take the power of itself is going to equal 1. Meaning x equals 1 is the only solution to this equation. So now to check, the original equation was x to the power of x plus 1 is equal to x. So x to the power of x plus 1 is equal to x. And our first solution is 0. So if I plug in 0, I get 0 to the power of 0 plus 1 is equal to 0. Now 0 plus 1 is 1, so I have 0 to the power of 1 equals 0, and 0 to the power of any number is itself, so I get 0 equals 0. Now to check for 1, I get 1 to the power of 1 plus 1 is equal to 1. 1 plus 1 is 2, so I get 1 to the power of 2 is equal to 1, and 1 to the power of any number itself, so 1 equals 1. Alright, so in this problem, I have x to the power of x is equal to 100. So I'm going to first start by taking the natural log, or ln, on both sides. So I have ln x to the power of x is equal to ln 100. Now, if I have something in the form ln a to the power of b, I can move this exponent and b to the front. So this is going to equal b times ln a. So for ln x to the power of x, I can move x to the front, and I'm going to get x times ln x is equal to ln 100. Now ln 100, that's the same thing as ln of 10 squared. So I get x times ln x is equal to ln 10 squared. And if I have something in the form ln a to the power of b, again, I can move 2 to the front, so I get x times ln x is equal to 2 times ln 10. Now, there's something called the W-Lambert function. And if I take the W-Lambert function of something in the form a times e to the power of a, this is going to equal a. So this is basically what the W-Lambert function is. So if there's something in the form a times e to the power of a, that's going to equal a. So what I'm going to do over here is I'm going to rewrite x here as e to the power of ln of x, because the e and ln cancel out, and this results in simply x. So I'm just going to rewrite x as e to the power of ln of x, and I have this times ln x is equal to 2 times ln 10. And now this is in the form a times e to the power of a. So now if I take the W-Lambert function on both sides, this results in ln x equaling w of 2 times ln 10. And now if I take e to the power of both sides, I get e to the power of ln x is equal to e to the power of w of 2 ln 10. And e to the power of ln x, that's going to equal x. So I get x is equal to e to the power of w of 2 times ln 10. And this is equal to 3.597285, which rounds up to 3.597. So this is my answer to this problem.